I think nuclear physics is about three big things. So the atomic nucleus is at the center of each atom and has basically all its mass. So it's the core of matter, and we want to understand how the strong force binds protons and neutrons into atomic nuclei. So that's basic science. It's just see how the strong force works. The second aspect is that atomic nuclei are also fuel of stars. And elements are made in stars and other stellar processes or astrophysical processes. And we would like to know where and how elements are being made. So again, to understand that, you have to know atomic nuclei and nuclear physics. And the third thing is maybe that we are looking always, or physicists are always looking for new physics, for things we didn't know before, or we want to understand certain feeble particles like neutrinos, or maybe dark matter better. And they all interact in detectors with atomic nuclei. So to interpret any signal you might see, or to really understand it, what could happen, again, you have to understand atomic nuclei. So it's for three things: the fundamental strong force, understanding it, where and how elements are made, and how do feeble particles interact with other stuff. I would say about 20-25 years ago, there was really a big change in the field. Computers always have been powerful and are getting more powerful every year, we know this, but about that time, one could really do qualitatively things that one couldn't have done before, that were interesting. And so since 20 years, it has just become more and more interesting. The models that we can build are more and more reliable, more and more complex. And so bigger computers allow us to be just more accurate, to model also small details better. And that has just changed the field fundamentally. Classical computers are very powerful, but then there are new technologies, quantum computers, and they are supposed to become very powerful in the next 5 or 10 years. So certainly, we want to make use of them as well, or machine learning techniques. Computing the structure of an object, that's one thing. It has many details and you have to capture them. But then imagine that object is moving, so that's dynamics, moving things. Or even things are colliding, smashing into each other, particles get emitted. So it's now a very complicated and complex scenario. So this makes it a much bigger computational challenge than just to take basically one snapshot. And it's interesting because though we use technologies like fusion and fission, on a very basic microscopic level, they are not really well understood. So we have a lot of data, we have measurements, we can build reactors, we are trying to build fusion reactors, but how fission really works on a microscopic level, how, say, an object consisting of 240 protons and neutrons suddenly splits itself, emits neutrons, that's hard to understand on a microscopic level. And so now, with computers becoming ever more powerful and having reached a maturity really, we can tackle those problems